Hi, this is lesson 16, and today we're going to talk about outliers. And here's what an outlier is. An outlier is a data value that's dramatically different than the rest of the data values. So we'll record this. This are outliers. Outliers, well, that was some funny looking letters. Let me clean those up. Outliers are data dramatically different than the rest of the data. And what they do is if you have a low outlier, so we'll write this down, low outliers are small values, low or small outliers. Small outliers skew the data left. And large outliers skew the data right. And a quick review of that is when we talk about left skewed, our data, well, let's do this. We've seen some of this in our homework, but when data is left skewed, what happens then is, say you have a bunch of data like this, and most of it is all piled up around here. If you have one really small data value, then what happens is that the mean gets shifted to the left. And then if you have right skewed data, then you'd have a similar picture, but now it's the other way. Instead, maybe now you have your pile of dots out here. Oops, I could make better dots. Let's make better dots. So my dots now, they might look like this. But now I might have a data value far off to the right. And so this takes and moves the mean to the right. And the question is does that value dramatically affect the data, or is it just a little? And we'll start with an intuitive example, and then we're going to formally define what an outlier is and how we decide if one is. So we have an example here. Let's take an example. And I'm going to give you a data set. And here's the data set. It's 19 and 18, 18 and 0, 17, 17, oops, make a better 17 there, 17, a 19, and a 20. And then let's pretend, suppose these are students' test scores. Suppose the data is a student's test scores. Okay, let's start. And the first thing we're going to do is let's draw a dot plot. Now, the reason for doing this is just to get an idea of, well, what does this data really look like? Now, I'm going to have to work a bit hard here because that data is spread out over 20 units. So let's just start with our dot plot, about like that. And we'll go down here to 0, and then we'll just start counting off after that. So here we go. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There we go. We have our 20 values. And I'm going to just really quick here, let's just put a better line in there. Okay. Now, let's start recording the scores. So I have, let's see, I have a 19, so I'll record that. I have two 18s, 1, 2. We have a 0 way down there. And then we have two 17s. Those will go right here. I can label that too just to help clarify. I have another 19. We'll put that here. And finally, we have a 20. Okay. Now, the first thing I want to do is we want to see, does that 0 dramatically affect the student's test scores? Because if it does, then that would be an outlier. So let's take a look. So if I want to calculate the mean, then I would add up all my data. So I would go 0 plus, I have two 17s, so let's just go 2 times 17 plus, I have two 18s, so I'm going to go 2 times 18. I have two 19s, so we'll do the same, 2 times 19 plus our last value of a 20. And we're going to divide that by our total number of scores. And if we count these up, we have 1, so I have 1, 2, 3, 4, 5, 6, 7, I have 8 values. So I need to divide all of this by 8. And so let's just take a moment and add these up. You'll probably beat me. That's a 34 plus a 36 plus a 38 plus a 20. All of that is divided by 8. Let's see, that's going to be 70 plus 58. That's going to be 128, I think. I think I might have done something. No, I think that's right. Let me just double check. I have my handy calculator here. Yeah, and that's going to give me 16. So I'm going to put this in blue. We'll put this right below here with that 0 in the student's test scores. The mean is 16. Now, we're going to recalculate this. We're going to, and let's do this. Let's also find the 5-number summary. Five-number summary here. And so it looks like I have a minimum. I can see the minimum. That's not too hard. I have a minimum of 0. And then I have a maximum, or we'll put them in order. Let's do that. So Q1's a little harder to find, and Q2 is as well, and Q3 takes a bit of work, but the maximum, that one's an easier one to find, so we know that's 20. All right, now I'm going to use a different color here just to keep track. So notice if I have 8 values, that means the median falls between, so would divide my data into 2 groups of 4. So if I count them off, let's count them 1, 2, 3, 4. And if I count from the top, I'd go 1, 2, 3, 4. And so between the 4th and the 5th value, that looks like it's an 18. So Q2 is 18. Now, Q3 is going to be split these upper half. Now I have 4, so that means it would split it between 2 and 2. So if we used another color for Q3, we'll use purple here. Notice I have 1, 2, 3, 4 values above, and so it looks like Q3 is 19. Okay, and finally we'll use one more color. How about orange? You can see that if I want 2 values, so now I'm looking at 1, 2, 3, 4 values in the lower half. So if I count 1, 2, so it looks like Q1 is a 17. There we go. That's my 5-number summary with this data. And you can also make a box plot of that. You'll see what it would look like. I would encourage you to try that. And actually, we could do a box plot. We can put that box plot, sure, let's do one in pink. And notice that we have our values. We know that our minimum is 0, so I'll come right up above the 0 here. And I have Q3 is 19, so we put a line, 0, 17 is my Q1, so let's come over here. There's a 17. I have an 18 for my median, a 19 for Q3, and a 20 for my max. And there is the box plot. And you can see it's really kind of stretched out a bit. Okay, now we're going to pause here, and in the next video, we're going to look at, well, what happens to the data if the 0 is removed, See you in a little bit. Thanks for watching.